So today we'll be discussing the topic multi-class classification in the course of machine learning. So we have seen the binary classification. So in binary classification we have two classes. In binary classification we have only two classes. So for example, you take so whether a patient has a cancer or not, based on the tumor size we will be able to tell. So is he having cancer or not having cancer? So there are only two classes. So the class is having cancer or not having cancer. So not having cancer is nothing but healthy. So there are two classes, having cancer and not healthy. So that is binary classification. So whereas a multi-class classification is that, so given the training data set we have the target variable. The target variable can take different classes. For example, if you take the basket of fruits, it may contain three different fruits like orange, apple, banana. There are three classes. Okay, so in that case we have to use multi-class classification, right? Suppose we take the Google Gmail inbox. So suppose we are getting mails from different things, like we are getting mails from friends, we are getting mails from the office, we are getting mails, some marketing mails from different companies. So we got three classes here, mails from friends, mail from office and mail from marketing companies. So we can separate them into classes. That is called a multi-class classification. So if you compare the binary versus multi-class classification, so here we have only two options, yes or no. So suppose a mail is spam or not spam, whether a patient is having cancer or not, yes or no. So we have yes means positive example, no means negative examples. So these are some of the examples for binary classifications where we use the confusion matrix, which is very simple. So whereas in multi-class classification we have multiple classes, there exist multiple classes in the target variable. So we assume that there is no overlap in the classes. For example, okay, so we have three classes, class 1, class 2, class 3. There should not be any overlap. They should be exclusive. That means you should not combine two classes together. For example, so what is the example? You take the strength of a person. So we can classify that very strong, moderately strong and weak. So here there is no overlap, but if you consider, if you combine two classes together, like a person is strong and tallest, a person is strong and short. So if you combine like that, it is not, we call it as multi-label classification. So we are not discussing that. We are focusing on when the classes are exclusive. So here what is our objective actually? So we are given with the input space x and the number of classes is equal to c. So and we are given, we have unknown distribution. So we don't know what is the distribution, how they are. So what is our expectation, what is our objective is, we have to find a hypothesis function f of x which minimizes the expectation of losses. So here we are taking 0, 1 loss. So if you are not predicting correctly, we will get a loss of 1. So if number of predictions are wrong, the loss will increase. So it is expectation of loss function. So we have to do it over all the classes, and we have to find, we have to learn hypothesis f which can minimize this loss. So what are different types of, how do we achieve the multi-class classification? So basically there are two types of multi-class classifications. So one is one versus rest. It is also called one versus all. So one versus all. Another one is one versus one, or it is also called all versus all. So there are two types. One is one versus rest, and another one is one versus one. So what is the meaning of that? So one versus rest means, suppose we have three classes. Suppose we have three classes like fruits, as we discussed. There is a class of fruits, orange, banana and apples. So here one versus all means we will will take one class and treat all other classes as a single entity, that is rest. Rest means remaining. So, one versus remaining classes. So, we have to do it for all the classes. So, first one is orange versus not orange. Not orange covers bananas and apples. So, next step is banana versus not banana. Not banana covers orange and apples. So, next one is apple versus not apple. Not apple means it may be banana or apple. So, like that we will get 3 models. So, in one versus 1, the number of classifier models equal to number of classes. Suppose we have taken 3 kinds of fruits or 3 class of fruits. So, we will get number of classifier models equal to 3. That means we have to learn, the system has to learn 3 models, classifier models. Okay. So, when it comes to 1 versus 1, so it is like if there are 3 classes, it is like 1 versus 1. That means we have to take only 2 at a time. We have to take only 2 at a time. Suppose there are C number of classes, then we have to select only 2 among them. Suppose we have 3 types of fruits. At a time we can select only 2 fruits, 2 fruit classes. So, how many will get 3 C2? Okay. If there are C classes, C C2, that is C factorial by C minus 2 factorial by 2 factorial. Okay. Which is nothing but C into C minus 1 by 2. For example, there are 3 classes means we will get 3 into 3 minus 1 by 2, that is 6 by 2, 3. So, that means we will get 3 classifier models. Suppose you have 4 classes in the given data set, then we will get 4 into 4 minus 1, that is 4 into 3 by 2, that is 12 by 2, that is 6. Okay. So, that is about 1 versus 1. So, let us go and discuss a little detail about OVR or OVA. So, here we are taking 3 examples, 3 classes are there in this figure. You see, we have taken 3 different shapes, you can see. So, the first one is you can say it is a rhombus symbol, and it is a cylindrical symbol, and it is a polygon. So, there are 3 classes, class 1 is this, class 2 is this, and class 3 is this. So, now we want to apply 1 versus rest. That means the first one is class 1 versus remaining. So, okay. So, class 1 versus remaining. So, you can observe earlier we have cylinder here, we have polygon here. So, we are treating entire thing as some symbol. So, we have only 3 classes as modified as we have to modify the training data set like a binary. So, how do you modify is we are interested in class 1 versus remaining. So, the remaining is treated as not class 1. So, class 2 is treated as not class 1, class 3 is treated as not class 1. So, only 2 things are there. What is that? Either class 1 or not class 1. So, it is positive example, it is negative example. So, you have to modify the given training data set into binary classification data set. So, this is after okay, modifying the data set, we have to land the hypothesis function h. We have to learn the hypothesis function h given the modified training data set and given the parameters theta. So, after learning, so it will give a decision boundary like this. So, we call it as h theta 1. So, 1 denotes it is the classifier model for class 1, classifier model for class 1. It separates class 1 versus the remaining classes. So, similarly, we do it for the second class. So, we do it for the second class. So, what is our second class is cylindrical. So, cylindrical versus non-cylindrical. So, here you can see we have so class 2 versus not class 2, class 2 versus not class 2. Okay. So, there are only now class 1 is modified as it is not class 2, it is modified as not class 2. So, we have to modify the training data set like class 2 or not class 2. We should not talk about class 3 and class 1 here. Okay. So, that is class 2 versus the remaining. Now, So, we will see the what is the last one. Obviously, we have class 3 versus remaining, the class 3 versus remaining. Okay. So, how it looks. So, what is our class 3 is polygons, polygons versus not polygons. So, we are indicating not polygons as not class 3, it is class 3. So, class 3 versus not class 3. So, now also we have to learn a model, that is H3. H3. So, it is the hypothesis we have to learn that separates class 3 and not class 3 models. So, this is called the, it is what we have to learn from the given data and given parameters. So, how do we learn already, if you know logistic regression, as we discussed in the class. So, we can use H is equal to 1 by 1 plus e power minus z, which is based on sigmoid function. We can develop a logistic regression model to classify, okay, as we have done in the binary classification. So, what we have to learn? So, we have to learn 3, because there are 3 classes, we have to learn 3 hypothesis functions that separates the class 1 versus not class 1, that is H1, and class 2 versus remaining, that is H2. Similarly, class 3 versus the remaining. Okay, so we have learned 3 decision boundaries, H1, H2, H3. So, let us combine all the 3 now. So, this is my H1, this is my H2, this is my H3. So, you are now comfortably classify class 1, class 2, class 3 by using the decision boundaries H1, H2 and H3. Okay. So, good that we classified, but how do you test? Okay. So, this is the training part. How do you test? So, in order to test, you have to take a testing point. So far we trained, okay, the binary classifiers, sorry, the multi-class classifiers. So, S theta C, C denotes class number. So, it is like estimating the probability of being class C given x and the parameters theta. Okay, for example, the first hypothesis. So, what is the probability of being class 1 given the training data set x and theta? So, similarly, you can find H2 and H3. So, how do we train? Already we discussed. So, how do you test it? Take a test input x star to predict the class. So, what is our objective is find the class C that maximizes this, okay, that maximize the probability of being class C. So, we have the training, we have the test data. So, plug in the test data, find out H1 what is the probability, H2 what is the probability, H3 what is the probability. So, which is giving the maximum probability, that is your class. So, to illustrate this, let us take a the same thing in as a data set. So, say we have some features already we indicated in the graph x1, x2. So, this is the class, RH means rhombus, CY means cylinder, PO means polygon. So, this is our data set. So, RH means class 1, CY means class 2, PO means class 3. So, we have 3 classes. So, how do you apply one versus all or one versus rest classification technique? So, here as I already discussed, we have to modify the training data set. So, we should not use this because we have to resolve this as a binary. So, what we have to do is we have to develop training data set for class 1 versus rest. So, class 1 versus all. So, we have to develop that. So, in order to develop that, okay, so we have to modify the data set. So, how to modify the data set is we are talking about RH, okay, rhombus versus not rhombus. So, wherever rhombus is there, treat it as positive, example +1. Wherever other shapes are there, treat it as negative. So, here we have RH. So, here we have RH, right. So, here RH, so treat it as positive. So, here also we have RH treated as positive. So, all other shapes treated as minus or -1. Okay. So, this is how do you modify the training data set. So, now it is resolved as either class 1 or not class 1 or not class 1, okay, or you can say minus 1. So plus 1 means class 1, minus 1 means it is not class 1, okay. So we have done it for class 1, so we have to do it for class 2 also, similar procedure. So we are modifying the training data set class 2 versus not class 2. So wherever class 2 means cy, so wherever cy is there, mark it as plus, remaining as minus. So we got this training data set, give it to logistic regression and learn H2 given this training data set. So given this training data set, so learn H2, okay. So do it similarly for class 3. So we'll get this, that is class 3 is nothing but polygon. So learn H3 here. So after that, say we got some result like this. So we give some test data. Suppose calculate H1, H2, H3. So H1 you got 0.95, H2 is 0.35 and H2 is 0.35, H3 is 0.45. Among all this, what is the highest is 0.95. So that is our class. So class 1 is the answer for the some test data, okay. So like this we can apply 1 versus all, okay. So the next one is 1 versus 1. So 1 versus 1 is also, you can call it as pairs. So 1 versus 1, okay, you can call it as pairs or all versus all. That means if there are n classes, so at a time we can take only 2. At a time we can take only 2 classes. That's why suppose what models I can get, 1 versus 2, 1 versus 3. So 1 is completed, right. So 2 versus 3. So we'll get 3 classifier models, okay, that is 3C2. So which is nothing but 3 into 3 minus 1 by 2. So number of hypothesis functions equal to NC2 or 3C2. So that is here how much? 3, okay. So 1 versus 2. So what is the, we will write it as H1 comma 2, because it separate class 1 versus class 2. It will, okay, we have to delete this data. When you are comparing 1 versus 2, so delete class 3. So when you are comparing 1 versus 3, so we have to delete class 2. When you are comparing 2 versus 3, you have to delete class 1, right. So let us see that in slides. So you can observe this is nothing but class 1 versus class 2. So now you can see there is no class 3, okay, we have deleted it. So learn a decision boundary between class 1 and class 2, which is H12, that separates class 1 and class 2. So what do you learn is we can use logistic regression, okay. So similarly class 1 versus class 3, class 1 versus class 3. So learn a decision boundary between class 1 and class 3, okay. So similarly 2 versus 3. So learn a decision boundary or hypothesis H23 between class 3 and class 2, okay. So after learning all these things you can combine, so which looks like this, so which separates the classes, okay. So you can see H12, so it should be not H1, okay, it should be like this. So H12, H13 and H23, so comfortably separates class 1, class 2, class 3. So we have completed the training part, Okay, so with training data set we land H12, H23 and H13. So now, so how do you test it? Okay, so how to test it is, so you can say, so how to test, okay. So initialize the score. So define some score for each class. Okay, define score for each class. Okay, so initialize is score equal to 0. That means we have, okay, score for class 1, score for class 2, score for class 3. So make them all 0 initially. Okay, now suppose there are k classes in 1 versus 1, that means k is nothing but n into n minus 1 by 2. If n is number of classes, okay, n is nothing but number of classes available. But how many classifier models we have? So okay, so here k denotes, okay, number of classifier models. So how many models? Okay, it is not number of classes, it is number of classifier models. Okay, so k denotes number of classifier models which are given by nc2. n is number of classes. Suppose there are 3 classes, k is nothing but 3c2. If there are 4 classes, 4c2. Okay, that is okay. Now, so what is the algorithm is, okay, first okay, we write it 2 for loops. The first for loop is for 1 to k minus 1. That is, for example, if there are 3 classes, I belongs to, there are 3 classes, that is n is equal to 3, then k becomes 3, because okay, k is nothing but nc2. Suppose n is 4 means, then we will get 4c2, that is 6, then it belongs to 1 to 5, but we are discussing about 3 classes. So for I is equal to 1 to nc2, that is here we will get 3, so k minus 1, 3 minus 1 is 2. So what about j? So when I is equal to 1, when I is equal to 1, j belongs to 2 comma 3. When I is equal to 2, when I is equal to 2, okay, that is second iteration, j belongs to I plus 1, that is will get, okay, j belongs to 3. So okay, so I plus 1, okay, so j belongs to 3. So when I equal to 1, so what we will get is, I is 1 means, so what are the things we will get? We will get here h 1 2, h 1 3. So when I equal to 2, what you will get is h 2 3. That means, okay, we are calculating the probability, okay, of belonging to a particular class from these hypothesis functions. Okay, so here y is nothing but your h ij of x. So okay, suppose it belongs to, okay, ith class, we will get plus 1 here. Suppose it does not belong to ith class, you will get minus 1 here. So again, if it belongs to ith class, you will get plus 1. If it does not belong to that class, we will get minus 1. So that's why if it belongs to this class, it is incremented. If y is plus 1 incremented, y is minus 1 means decremented. Okay, so calculate score for because we are talking about h I j. So modify the scores for ith class and jth class. If y is positive means it is incremented, it is decremented. If y is negative means it is decremented, it is incremented. Okay, so calculate the scores for the ith class and jth class for each h function. So after completing these two loops, so final task is we have scores for all the classes. Here there are 3 classes. Calculate the score for score 1, score 2, score 3, which is giving highest score, that is your answer class. Okay, so this is about 1 versus 1. Okay, so how do you modify the training data set for this 1 versus 1? So this is the given data set. So how do you modify this for 1 versus 1? Okay, so 1 versus 1 means only 2 classes should be there. So here I want to classify class 1 versus class 2. Okay, so class 1 is RH, class 2 is CY. So don't worry about this. So simply delete that. So first delete this, delete this. Okay, because we want class 1 versus class 2. So class 1 is treated as positive, class 2 is treated as negative. So that's why class 1 is RH, so plus it is treated as minus. So now you will get only 4 samples. Okay, from the given 6 samples we will get 4 sample training data set for class 1 versus class 2. From this you have to learn H12, that is you have to learn the hypothesis or decision boundary that separate class 1 and class 2. So do this activity for the remaining, that is class 1 versus class 3. So here also you have to delete class 1 versus class 3 means you have to delete class 2 CY. So you have to delete second one and you have to delete fifth one. Okay, then you will get this training data set. From that you have to learn H13. Next, class 2 versus class 3 means CY versus polygon, cylinder versus polygon. So here you have to delete RH. So you have to delete RH. So class 2 versus class 3. So 2 is treated as positive, CY is treated as positive, remaining is polygons are treated as negative. So we will get 4 sample training data set. Okay, so from this you have to learn H23. Okay, so like this you have to learn 1 versus 1 classifier models H12, H2, H13, H23. Okay, once you learn you can apply the testing algorithm as we discussed. Okay, so thank you very much. Okay, so today we discussed about multi-class classification and